Now that we have taken care of all these pre-requirements, we can deploy GitLab itself and set up our CI/CD pipeline. So the big picture with GitLab is that GitLab is going to be a Git server, meaning something that we can Git push to. And each time that we push a bunch of commits to GitLab, GitLab is going to build container images corresponding to these commits, and then it will create a staging namespace and deploy these images in that staging namespace. And then we're going to have a special separate namespace for production. And when we push to the production tag or branch, it's going to deploy these images in that production namespace. Now, this is just one of the many workflows that we could implement with GitLab. Some folks prefer to have separate clusters for staging and production. Some folks prefer to not have a production namespace, but instead have your staging namespaces. And when you want to put to production, what we do is that we promote one of these namespaces to be the production namespace. So this is kind of getting us closer to the concept of blue-green deployment, for instance. So with GitLab, we define the specific workflow that we want in a YAML file. And I'm going to give you a quick look at the one that we will use. We're going to come back to that, so I'm not going, to peel off all the layers in that file right now. But you can see that we have a few stages defined here: lint, build, deploy. And then for each of these stages, we have multiple steps that are going to happen in parallel. So don't worry too much about these details for now, but just know that everything that's going to happen when we push our repo is defined in that file right there. And there is like this notion of parallel stuff. So that's pretty powerful, because it means that if we have a bunch of images to build, or if you have linters and tests and this and that and whatever, all that can happen in parallel. And at first we could think, okay, what's the big deal with stuff happening in parallel? Well, that means that it reduces the total execution time. It means that when you push your code, you might have to wait just a few minutes instead of a few hours to see the results, and that's really important. It's kind of one of the big things that we're trying to achieve with DevOps, is to reduce the time it takes between I make some changes and I can see the results, whether it's something that I do in dev or staging and I just want to make sure that my changes are good, or if it's more like a production experiment, like if I deploy something in production and I want to wait and see the results to know if I should go farther in that direction or not. So we want to reduce that time as much as possible, and so having stuff in parallel is actually a pretty awesome thing. All right, so as I mentioned earlier, and the reason why we had so many things before getting to GitLab itself is that we have all these requirements. We need a domain name, we need to have some storage, we need to have TLS, we need to have valid certificates, and of course we need GitLab itself. And I mentioned that a few times, but I'm going to kind of give a little bit more details about these requirements now. Like, why do we need all that? Why can't I just deploy GitLab and be done with it? Well, the main reason, like the big thing, is that when a container engine pulls images from a registry, and so when I say container engine, that means Docker, but also Containerd and pretty much every other container engine that I know of, they insist that the registry speaks TLS and has valid certificates. So we need to have a valid certificate on the registry. So there are a few options here. The one that we're doing here is that we're using a real certificate obtained with Let's Encrypt, because in my opinion, that's the best solution. That way we're not, trying to finagle a way around and ending up bumping ourselves in some weird side effects or whatever. No, we get a real certificate. That's, I think, the best option. Other options would be to use a self-signed TLS certificate, but if you do that, then you need to go to every container engine that you're going to use and add your root certificate there. And not just the container engine, but every tool that's going to touch your registry will need to have that certificate added as well. So just to give you an example, let's say that you decide to plug some image scanner in your pipeline. Your image scanner is going to talk to the registry, so you will need to add the certificate there as well. And it might not look like much, but trust me, that quickly becomes a nightmare when you have to plug this CA everywhere. Sometimes it's as easy as just dropping the right PEM file in the right directory, and sometimes it's just hell because there is some tool somewhere that's using some image from you don't know where, and so you need to augment that image with something. But I really don't recommend to use self-signed certificates here, except in some highly specific scenarios. Another option is to use a registry that is on localhost. What I mean here is that if I do, like a Docker pull localhost on port 1234 / blah blah blah, since it's localhost, the container engine is not going to require TLS. So that's an option, but it's not always practical to use because it means again that each time I will want to talk to the registry, I will need to do it over localhost. And again, there are some hacks around that. So especially, if you are comfortable with tools like Socat and IP tables and etc., you could try and go that route. Again, personally, I don't recommend it. Just use real certificates and you'll be on the safe side. All right. And I've got some extra details here in the slides, just if you're curious about that. I would say, I was mentioning special cases. I would say that one of these special cases would be when we work in air-gapped environments, something that is completely isolated from internet. And then you're like, okay, I can't really obtain a certificate. And then in that case, maybe we can think about these solutions. For instance, using localhost, because one of the flip sides of using localhost, and again, not diving into too much details here, is that if you have a registry running on localhost, often we will use techniques that will make that registry available without TLS to everyone. So over the big wild internet, it's not a great idea. Now, if you are in an isolated air-gapped environment, maybe it's not a big deal. So anyway, another thing for folks who skipped over the first few chapters and were like, oh, I don't want to buy a real domain name to do this. Can I instead use something like nip.io or xip.io? Technically, you can. In practice, though, it doesn't always work well. Why? Because nip.io, xip.io, you end up sharing the same domain with a bunch of other folks. And when you obtain your certificates, Let's Encrypt has a quota, which in 2020, and I don't think that changed in 2021, is about 50 certificates per week. And I'm going to tell you a really short story about this. The first few times that I demoed Let's Encrypt with Kubernetes and all that stuff in some workshops and trainings, I was like, okay, let's use an nip.io and let's obtain some certificates. And so I run the demo and everything works great. And the first few students who do it, it works great. And then starting with the maybe 5th or 10th or 20th person, it doesn't work anymore. And it doesn't work at all from that point because we exhausted the quota for nip.io. So to avoid that, now I'm like, okay, let's use a real domain name so that we sidestep the issue. All right, well, so now we're going to use the GitLab Helm chart to install GitLab itself, and brace because that's going to be a fairly big Helm install command. So are you ready? This is our Helm install command. All right, look at all these wonderful parameters. I'm going to explain the role of all these parameters, but first I'm going to run that command because it's going to need about 10 minutes to, pull everything and have all the components start initialize. So I'm going to run that, and then I will get back to explain what all these parameters are doing. So first things first, let's add the GitLab repo to our Helm install. And once again, when I'm going to run this myself, it's going to tell me, hey, you already have the GitLab repo, so okay, we're good. Then I'm going to set an environment variable with my domain, cloudnative.party, and here, of course, put your own domain, not mine, otherwise that's not gonna work. I'm gonna put the name of the Let's Encrypt issuer that I'm using, so that's the one that we configured earlier. And then there comes that big Helm install command here. So, all right, let's run that. Okay, the beginning is classic stuff. It's that whole Helm upgrade -- install GitLab. So I install GitLab in its own namespace. I create the namespace if it doesn't exist. All right. Now, what is all that? Okay, so that one is relatively self-explanatory. We set the domain that GitLab will use to generate all its URLs. So there are lots of other parameters that are going to be set from that one. So the address of GitLab, for instance, is going to be gitlab.that domain. Then cert manager install false, nginx ingress enable false. Here we're basically saying do not install cert manager, do not install the nginx ingress controller, because we are using the global ones that we did install earlier. Now these parameters, global ingress class, global ingress provider, as far as I can tell, the exact value doesn't matter too much. It's just going to trigger a few things in the chart so that it understands that it needs to create a bunch of ingress resources. So for the GitLab web server, for the registry, and for Min.io, if I remember correctly. That one, configure cert manager false, means do not create a cluster issuer because we will provide ours. Now this means add an annotation to all the ingress resources that you will create. So we're using the trick that I showed you earlier, where by simply adding this annotation to an ingress resource, Cert Manager is going to notice and it's going to obtain a certificate for that ingress. Now these three options here, you can see each time it's GitLab, registry, Min.io, .webservice, .ingress, .tls, etc. Like these options here, they simply add a TLS section to the ingress resources. And here we need to pass these options, because if we do not pass these options, then the chart will not add a TLS section in the ingress resource. And so even though we have this annotation here that says obtain a certificate, if we do not have a TLS section, the Cert Manager won't do anything about it. Traefik will not enable TLS on these ingresses, so we need these options as well. All right, so we reviewed that, perfect. Now let's see what's going on in the cluster. So I'm going to, let's go to the GitLab namespace and let's have a look at everything that's happening here. And as you can see, there is a lot happening right there, okay? So I'm going to use K8s, for instance, because that's the perfect use case for that in a way. So that shows me all the pods, and this is going to take a while. And we are going to see these pods come up kind of slowly, one after the next. And to clarify a little bit, it's not just because, it's not because these things need a really, really long time or whatever, but it's because we have lots of dependencies. So for instance, you might have this runner here, and if I remember well, the runner relies on the web service, because if I remember well, the runner is just trying to connect to the web service. We might even be able to see that if we go here. We can see something like fail to register the runner, you may have network problems. Oh, there you go, see? It says can't execute post against https gitlab.cloud native party. So the runner is trying to connect to the GitLab service, but the GitLab service, the web service, is not up yet. And if we look at that one, we see that it's still running some init containers. So if we try to have a look, we're going to see that these init containers have, wait for depths, basically. It's waiting for other dependencies to be up. Which dependency exactly is it waiting for? It's a good question. I know that there is a thing that waits for the Postgres database, but now the Postgres is up and running, so actually these ones might start soon. To be honest with you, this is going a little bit faster than usual. When I've been running these as a test, very often it took anywhere between 10 and 15 minutes for everything to come up. Well, I mean, everything is not completely up yet, but we're already in a pretty good shape here. We will have success once everything is in running or completed, and when all the containers are ready within a pod. So here it's pretty nice with K9s because we can see, like all these pods in white, they're fine. This one is in red because it's running, but as you can see here, all the containers in that pod are not ready yet. The pod is running, the container is running, but the container is not ready yet. So we have like this kind of red warning. Now if we look at these ones, now the GitLab web services are starting, so that's great. It's going to take them a moment as well. We can actually take a look at the logs here. Okay. And in the meantime, we have the whole DNS thing happening, so we have ingresses as well. Let's go to ingress. So with K9s, we do colon, and then we type the type of the kind of resource that we want to see, like ing ingress. Now I can see my ingresses, and it's pretty interesting. I see that I have this ingress right there, which corresponds to min.io. I don't see an Acme HTTP solver for registry and GitLab, which I think means that these have been processed already, if we're lucky. So let's go back to oh, we could look at deployments as well. So the deployment view, that's also interesting because these colors immediately tell us which ones are okay and which ones aren't okay yet. We can see that the runner is not ready yet, Sidekick is not ready yet, and the web service is not ready yet. The web service is the one that we're waiting for to be able to access GitLab itself. I can go back to the pods. So colon pod. And we just have to wait for the web service to come up. It's going to take a few minutes, so I just suggest that we fast forward a few minutes to the time where all these pods will be running ready, and then we can go and configure GitLab. And about 5 minutes later, here we are all the pods are up and running or in completed state. If you're wondering why do we have some pods running and some pods completed, the ones that are running correspond to pods controlled by deployments or stateful sets like these ones, and the pods that are completed correspond to pods controlled by jobs. So the difference between a deployment and a job, for instance, is that the deployment should remain up at all times because it's some kind of web service or worker or something like that, while a job is a thing that runs, so it has a beginning, it runs an end, and then when it's done, and then it shows up as completed. So now we can connect to GitLab and configure GitLab. So how are we going to do that? Well, we are going to connect to GitLab dot the domain name. So for me, that's gitlab.cloudnative.party. See how we're connecting over HTTPS, so that's great. And here I need a username and password. Okay, how are we going to find that username and password? Well, earlier when we did the section on Prometheus and Grafana, remember we went looking in secrets and we found a username and password. Well, we're going to do exactly the same thing. And let's look at secrets. And in the secrets, we have in particular, let's see, maybe I can zoom this a little bit for you. Yeah, perfect. GitLab initial root password. Well, I don't know what you think, but that seems promising. Now, when I look at this, it's telling me that, yep, there is a password, but it's some opaque data. So how can I see what's happening there? Well, let's exit K9s and we can do a kubectl get secrets. So GitLab initial root password -o JSON. So when I do that, I get a bunch of things, and what's relevant to me is that thing right there. Okay, so I'm going to extract that field. So pipe jq.data.password, and then I'm going to base64-d to decode base64. And sorry, let's tell GQ to give us some raw output, and there we go. That's our initial GitLab password. Yes, that's this very long string here. That's the GitLab root password. Okay, so the login is going to be root, and the password is that super long string. And once we are here, perfect, we are going to create a new project. So create blank project. Awesome. I'm going to call that KubeCoin because I'm going to deploy an app called KubeCoin. It's going to be the Docker coins that I showed you at the very beginning of this video series, but now it's on Kubernetes, so I call it KubeCoin. And I have a repo with the CI/CD pipeline like ready to go. Okay, create project. And then we will need to actually push our code to that project. So, okay, let's add an SSH key. So I'm going to list my SSH keys, and I'm going to get that one, for instance, and add it right there, add key. Perfect. Now let's come back to my KubeCoin project and let's look at the instructions to push our repo. All right, blah, 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 push an existing Git repo. Yep, that's what I want to do. Okay, so let's see. Let's move to some temporary directory and let's start by cloning the existing KubeCoin repo from GitHub. So that's here, jpetazzo KubeCoin on GitHub. So github.com, jpetazzo KubeCoin. Okay, and then I need to add my newly deployed GitLab server as a remote. So how do we do that? We have some instructions in the GitLab interface here. So they tell me to rename the existing origin and then remote add origin. I'm going to do something slightly different. I'm just going to call the new origin, like the new remote, GitLab. And that's the address that we should use. Okay, so git remote add GitLab, and then I put that whole address here. Okay, and now we are ready to push the repo. Are we? Let's try. Git push GitLab -u, and then boom, port 22, connection refuse. What's going on? Well, we're missing a few things. So we're going to talk about that and see how to solve that problem and see what happens. So when we try to push the repo, we got that error, connecting to gitlab.cloudnative.party port 22, connection refused. Why? Well, the big question to ask here is, what does gitlab.cloudnative.party points to? Where does that go? Well, that's our ingress controller. That's Traefik. Let's take a look. If I resolve that name here, okay, this is going to be that particular IP address. And if I take a look at my services in all namespaces, and I'm like, okay, find that one. Who's that? Well, it's the Traefik service. And let's show that in a slightly nicer way. Just show the Traefik namespace. There we go. So I can see that this IP address here, that's Traefik, which is fronting all my HTTP and HTTPS traffic. So there is nothing here on port 22 to accept SSH connections. So how do we fix this? Well, we could do some kind of roundabout way, instead of pushing to gitlab.cloudnative.party, we could set up a separate, GitLab SSH or whatever .cloudnative.party. No, I would like to be able to accept connections directly on that address here. And how do we do that? Well, we need to tell Traefik to accept connections on port 22 and to send these connections to GitLab. The thing that I'm going to do here is going to be specific to Traefik, but there's going to be similar techniques if you're using another ingress controller. Basically, there is nothing right now in the Kubernetes, API specs, etc., to define something like this. There is nothing to say, oh, I would like this to be an ingress controller, but I would also like to forward this TCP connection on that particular port. So each ingress controller will have its own particular way to implement this. So in the case of Traefik, it's a two-step process. First, we need to tell Traefik, open port 22, accept connections on port 22, and then we will need to tell it what to do with these connections in the second step. So let's look at these new options for Traefik. So these options, we already had them before, but now we say, I want to create a new port. In the Traefik documentation, they are also called entry points, like a point of entry for Traefik. And we say, this is going to be port 2222, but the expose port is going to be 22. So you might wonder, hey, why do we need these two different ports here? Can't we just have port 22? Kind of. I think I already mentioned that earlier, and maybe you already know that, but on Unix systems, we cannot bind a port below 24 if we aren't root. and Traefik runs as a non-root user, and therefore it cannot bind ports below 22. So we tell Traefik to open port 2222, but then we tell it that this port is going to be exposed on the load balancer as port 22, and that protocol TCP here indicates that we're going to serve TCP connections, because just in case you're wondering, we can also have some UDP traffic going on here. So let's do that. I'm going to copy paste that block here, and so that's going to reconfigure Traefik. And after I do that, normally if I look again at that service, there we go. Now we have port 22. What happens if I connect to that port 22? You know, like if I try, for instance, curl on that IP address on port 22, it tells me 404 page not found. Same thing if I try with GitLab. Actually, if I put gitlab.cloudnative.party, I think this is going to send me to the GitLab website. There we go. I get a redirection right there. So for now, we have this new entry point, like this new port 22. It's open, it's accepting connections, but it's not doing anything special with them. It's just treating that as a copy of port 80 as you want. So it's doing the same kind of connection routing. So the next step is going to be, let's tell Traefik, hey, when you get connections on port 22, I actually want you to send that to the GitLab shell service. That GitLab shell service, so let's right there, GitLab shell, accepting connections on port 22. That's the one that we need to connect to. So how do we do that? There are a few different methods, but the one that I use here is the one that I consider to be the more Kubernetes-y, if you will. I'm going to use a ingress route TCP. So this is a custom resource. This is a custom type that is handled by Traefik. So how do we read this? This means I want to create that ingress route. So I'm going to call it GitLab shell. Put it in namespace GitLab. It's important to put it in the right namespace because here we have a reference to a service and the service has to be in the same namespace. So it's important that we put that in the GitLab namespace. Entry points SSH. This refers to that SSH here. So we give the name of that port or entry point that we defined earlier. And here, routes, that means, okay, what to do when you have connections there. And here there is a little bit of magic. This is this Traefik specific thing. We have host SNI star, like wildcard. So the idea here is that normally when something connects, Traefik is going, to look at the first bytes, the first exchanges happening on that connection. If there is some TLS, it's going to do the SNI, the server name indication, to figure out what we're trying to connect to. And we can do some fancy routing here, but that particular match, like host SNI star, that's basically the wildcard to say, send everything that way. So send everything to the GitLab shell service on port 22. So let's put that in place. So I'm going to, if you want, you could like copy paste that YAML and apply it, or you can also copy paste that whole kubectl apply block here. So creating that thing, okay. And Traefik is going to pick that up virtually instantly. And now if I try to curl again, I'm going to get that weird response here, like receive HTTP 09 when not allowed. Let's see what happens if I connect to GitLab Cloud Native Party port 22 with Telnet. Now I get the SSH banner, so that means success. That means that connecting to port 22 on GitLab Cloud Native Party is indeed forwarding me to the GitLab shell server. And so now the next step will be to try and push our repo. If we want to be double extra sure that everything is set up properly, we can try with SSH. So I can do SSH git at gitlab.cloudnative.party, and okay, so I get this little warning here. Don't pay attention to this. This is because I ran this recently when doing a full run of the material, and so of course I had a different gitlab.cloudnative.party, but normally you should just have this little warning here asking you to confirm the identity of the key, and normally we should see this, welcome to GitLab root, and when you get that, then we know that everything is fine and ready and we can push our repo.